Okay, everyone, I'm gonna get started. We might get more people to join us, but I'm gonna get started. I'm gonna introduce Colin Stuart, which is the introduction for the session now. It's challenging our preconceptions, what the physics of time can teach us about innovation. Colin Stuart is an astronomy author and speaker. He has talked to well over 250,000 people about the universe, ranging from schools and the public to conferences and businesses. His books have sold over 100,000 copies worldwide, and he's written for publications including The Guardian, New Scientist, BBC Focus, and the European Space Agency. In recognition of his efforts to popularize astronomy, the asteroid, how is that, Colin? The asteroid 15347. Colin Stuart is named after him. A fellow of the Royal Academy, a Royal Astronomical Society, sorry for that. He's appeared on Sky News, BBC News, and Radio 5 Live, and been quoted in national newspapers, including the Daily Telegraph and the Observer. So please welcome Colin Stuart.
Thank you. So we all grow up with preconceptions. We use the events around us to build a picture of our reality. And quite often, it leads us astray. Being too familiar with something can lead us to build up the wrong picture. And I'm talking really simple sometimes. So here's a really simple question. Where is the sky? It's something we all know, right? It's up there. But it's not. If you think about it carefully, the sky is not up there. The vast majority of the Earth's atmosphere is beneath your feet, not above your head. And so even something as simple as that, when you have a bigger picture, when you change the perspective you're used to, see things very differently. I was at a school and a young girl asked me a question at the end. She said, "Why is space up?" And I said, it's not. It's everywhere. It's up, down, and all around us. So it can be incredibly simple. Something else that we're very used to, particularly being an island nation, is being at the seaside and seeing the tide go out. I'm sure it's something that we've all experienced. And we know what's going on, right? You're standing there at the coast and the water is moving away. The tide's going out, the water's rushing away from the beach. Again, that is not what's happening. If you change your perspective, if you see things from a bigger viewpoint, something else is going on. So we have tides because of the gravity of the moon. Our moon is holding the water of the Earth in place, creating a bulge on the side of the Earth nearest the moon. So what's actually happening? If you're in an area of high tide on the left, and you suddenly move to an area of low tide, it is not the water that's moving. It is you that is moving. The gravity of the moon is holding the water in place, and the Earth is turning you away from the water. So when you stand there at the seaside, you're sure you know what's going on. I am stationary and the water is moving. It's completely the other way around. The water is stationary and you are moving. So it's by changing your perspective, you get these insights. And it can be incredibly simple too. We all know that days are shorter than years. It's obvious. We have short days and we have long years. But that's only the case on the Earth. If you start exploring some of the other planets of the solar system, you see those rules don't apply. All you have to do is go to our nearest neighbor, Venus. And the situation is completely different. Because on Venus, the year is shorter than the day. That may sound completely perverse to us, but if we think about what those two words mean, it becomes pretty simple. So a day is the time it takes for a planet to spin once. And a year, how long it takes that planet to orbit around the sun. Now, for us on the Earth, our planet spins pretty quickly, 24 hours, and takes quite a long time to go around the sun, 365 days. But that's only true on the Earth. Look at Venus. Its day is 243 Earth days long, and its year only 225 Earth days. It'd be a very different place to exist on Venus. It would mean, though, that you had a birthday every day on Venus, even though you have to wait quite a long time for those birthdays. That's just our solar system. If we start looking at other solar systems, they look incredibly different. My favorite planet is not around the sun. It orbits another star. In fact, it orbits two stars. It's called Kepler 16b. In the middle of that solar system, there are two stars. So think about what life would be like on that planet. Every morning, you would see two sunrises. Every evening, you would see two sunsets. As you walked around during the day, you would have two shadows, one from each of the stars. And if that weren't spectacular enough, every 3 weeks, the two stars eclipse each other. So it would be a very different experience. So what I'm trying to say is, if you grow up with a certain set of rules, you might think those rules are universal, because your experience is limited to a very small subsection of reality. So we've got to be careful if we start thinking that rules are universal ones, when actually it's just because we're used to seeing them from one perspective. We're starting to push these boundaries and encounter some of these issues because we're now sending regularly humans into space. We're sending astronauts into space to live aboard the International Space Station. Typically, an astronaut would spend 6 months on board. And their life is very different to our life on the ground. For example, due to microgravity and weightlessness, they famously float around. They're orbiting around the Earth every 92 minutes. So they're seeing 16 sunsets and 16 sunrises every single day. And they're getting wonderful views of Earth from above. So this is an example of what life is like on the space station. Here is Tim Peake, the only British person to so far travel. And I was lucky enough last week to go to Cologne in Germany to visit the European Astronaut Center and spend a couple of days with Tim learning about what it's like to train and select to be astronauts. And so it's very different up there. And what you're going to see is that Tim with a very important delivery to the space station that he was going to unload. But they are starting to bump into the fact that time does not work in the way that we think it does on the Earth. So we're very used to time running in a certain way, and we're very used to time being different from space. For example, I have a lot of freedom in space. I can walk this way. I can change my direction in space and go back the way that I came. I can change the speed at which I travel through space. I can run, or I can walk, or I can get in a car. So I can change my speed and my direction in space. I can jump, I can get on a plane, I can go to the space station. But our experience of time isn't like that. Time always seems to tick at the same rate, and we're always moving in the same direction. Do you know of a way to reverse the direction of time and head back the other way? We don't know that yet. Do you know of a way that you can change the speed at which you go through time and get to the future faster? To us, space and time seem to be very different things. So time runs in a very different way. Now, Einstein told us over 100 years ago that the way we think about time is not the way that time works. He said that space and time are not two separate things. They are all bundled up together into something that he called space-time. So the rules that apply to space also apply to time. And it means that the reason why things orbit the Earth, for example, satellites and the International Space Station, is that the Earth, being a heavy object, warps the fabric of space-time, and so the satellite is caught in the depression that the Earth makes. So what does that mean? If I said to you that you ran a 100-meter race with Usain Bolt, and he got to the finish line faster than you, would you be surprised? You wouldn't. But if I said to you that if you ran a 100-meter race with Usain Bolt, and he got to the future faster than you, would you still believe me? But it's exactly true, because it's not space you're both running through. It's space-time you are running through. So the faster you run through space, the faster you get through time. Now the difference between you and Usain Bolt, even though we can run pretty fast, is so tiny, we don't notice. But we've started to notice with astronauts aboard the International Space Station. So if you want to know what a time traveler looks like, it doesn't look like the right. It looks like the left. That is Gennady Podolka. He is the cosmonaut that holds the record for the most amount of time spent orbiting the Earth. Nearly 900 days, all told. He was traveling through space-time faster than us because he was whizzing around the Earth. That means he got to the future faster than us. He is 0.02 seconds younger than he otherwise would have been had he not gone to space. He has time traveled to the future by 0.02 seconds. That makes him the greatest time traveler in human history, even though it's a very small amount. It may sound small, but it really makes a difference. And we rely on it all the time. Whenever you use your Maps function on your smartphone and you hit that button that says, "Where am I?" It works because it pings the satellites orbiting around the Earth. They're going through space-time faster than us. They are time traveling into the future faster than us. We have to correct for that. If we don't build in those corrections, the whole system would be useless. Within one day, that blue dot would be 10 kilometers out from where you are. So not only is time travel possible, we rely on it. We factor it in for our GPS systems. So why have you and I never noticed? It's not like we get on a plane and we fly to maybe America, and suddenly we're a lot younger than we otherwise would have been. How come we've never noticed? Well, this is how it works. Up the y-axis, we have the amount by which time slows. Twice, 3 times, 4 times, 5 times, up to 10. Along the bottom, how fast you're going, as a fraction of the speed of light. So 10%, 20%, 30%, 40%. You can see that this effect only kicks in any detail when you get to really high speeds. So we live down here. We're in this part of the graph because we currently can't travel very fast. So if you think time works in a certain way, it's only because you live down here. As technology develops and we get faster and faster machines, we're going to move to this part of the graph, and all the things we thought were true about time will be shown up to be wrong. All our preconceptions will be shown up for what they are. Mistakes, because you're only living in a limited part of the overall experience. If this graph looks familiar, it should. Because it's exactly the same shape of graph as the growth of technology. So as things get faster and faster, as more devices come online, as the Internet of Things really becomes a big deal, if you've based your business on ideas here, preconceptions you developed here, and you think that's still how it's going to work when we move into the future, it's not. They're going to change too. If something as fundamental as our ideas about time can be shaken by growth of technology, what else can be shaken by that too? So a quick recap. We grow up with preconceptions about the world around us. It's not unusual. It's just how we build up a picture of how the world works. But we've got to be very careful that we know the limitations of those preconceptions. That once we move into a new arena, whether that's moving from Earth into space, from Earth to Venus, or from the old way of technology into the fourth industrial revolution, the same thing applies. So what does this specifically mean for you here today? I realize this is an unusual topic, but it is very relevant for you. You're going to hear a lot of things today of people predicting the future. They're going to tell you this is what the world's going to be like in 5 years. This is what the world's going to be like in 10 years. Humans are terrible at predicting the future. We have a really lousy track record. Here's my favorite example. Who the hell wants to hear actors talk? Who said that? The president of Warner Brothers. So even him in his own industry could not see the big change that was coming. So for me, innovation isn't about second guessing what's coming next, because the chances are you'll get it wrong. For me, the best way to innovate is to put yourself in a position where you're the most agile. You're the most free to move when the change comes. And the way to do that, from my perspective, is to challenge your preconceptions. To say, what is a universal truth? And what am I being forced into misbelieving is one, because my experience so far has been limited. You don't want to do the equivalent thing of saying, well, of course days are shorter than years. That's obvious. And when you do the equivalent of moving to Venus, you realize you had the whole thing wrong to start with. So if you think of the whole of industry as a solar system, make sure that you know the rules of the whole solar system, not just of your home planet. How do you do that? How do you make sure that you know how do you expand your horizons? How do you do the equivalent of moving around to different worlds? You do it by expanding your network. You do it by making sure you're not in an echo chamber, that you're not hearing the same voices all the time, hearing the same things from the same people. Here's a really interesting study that was done at the Chicago School of Business several years ago. It looked at the success of individuals in their careers based on the network of people that they were part of. And what they found, so performance is up the left-hand side, and on the bottom is the constraint of your network, the size of your network. They found that success was pinned to not having the biggest network of people, but being the link between very many different groups. So having a large network, but you can bring in the information from these people, you can bring in them from these people, and you use that to advance your careers. So I think this applies to business too, to companies more widely. Because if you have a larger open network, and you're hearing from people outside of your industry, if you're hearing from astronomy authors, if you're hearing from opera singers, if you're hearing from people who do very different things to you, you're casting the net really wide, drawing in as much information as possible, and then you can see what's a preconception and what's not. So do stay in touch. I'd love to talk to you more about how this applies specifically to your industry. I think we need to get these extra perspectives in. We need to draw in things like space science and astronomy, more into things that are beyond academia and universities. So do stay in touch. We've got plenty of time for questions, I think. Thank you.
Thank you, Colin. Yeah, there is actually some time for questions, which is great. Thanks for keeping on time.
No problem.
Anybody, anything to contribute?
Can I get that last slide back up?
It's very interesting because it's not something you initially think about when you're thinking of IoT.
No.
But
I think it is relevant, but it's
very glad that you're here.
That's
Exactly. It's really opening our minds to other arenas.
Hi, Malcolm Newdick from Riverbank IT. I just wondered if you got any thoughts on the speed at which we think and the speed at which we work, because you're talking a lot about the speed of travel, but what about the speed of our mental travel and our ability to solve problems?
So one of the things that I find interesting is how we're going to cope with all this change. Because the nature of exponential growth is that you see the same amount of change in half the time. So if you think about the differences in the last 40 years, you're going to see the same in the next 20, and then the same again in the 10 after that, and the same again in the 5 after that. So how do you even begin to cope with that whole change? You saw in the video from Siemens, one of the people who said that they started with slide rules and no calculators, and now they're doing smart factories. But that same amount of change is going to be smaller and smaller and smaller. So I think a lot of psychology is going to come into it too, about how we adapt to those kind of changes. We're going to have to get very good at picking up new skills quickly, even more quickly than we already do. I think so maybe not the speed of our work, but the speed at which we can pick up new ideas.
Hi, Jennifer Major from SAS, a software company. So I'm curious, have you been personally involved in specific projects that you would call around IoT, maybe around IoT research or so on? If so, would you like to describe the most exciting one?
No, so I don't. I don't have anything to do with smart IoT at all. But I'm kind of coming in with a outsider's perspective because I think the two things are so closely linked. That was the kind of penny drop moment for me when I was sitting there and looking at that graph of that effect of time dilation and the graph of things like IoT and the development of technology. I just look, they were almost exactly the same. And so that's why I like to come to these events because I'm hopefully providing a complete outsider's perspective. So yeah, no, I write books about space, so I don't have any practical experience.
Over here. This might be the last one. So,
Besides this pattern, are there any other patterns that you have discovered?
So the other thing that I talk about regularly is the need to get different people working together. So on a kind of similar vein, there are some lovely examples of when two different teams of people have worked together and to create amazing things, and you wouldn't normally put them together. So for example, I'm talking about astronomers and medical doctors. They don't talk to each other. Why would they, right? But when they did, they realized they were doing something pretty similar. That looking at galaxies through a telescope and looking at tumor cells through a microscope are incredibly similar optically. When the astronomers shared with the oncologists, the cancer doctors, their software for analyzing images, they could suddenly diagnose cancer more quickly than a doctor and as accurately, particularly for breast cancer. So one of the other things is that I'm keen to talk about is the sharing of ideas, as I was talking about at the end, of drawing disparate groups together, because innovation for me isn't doing the same thing twice. If I'm doing it and you're doing it, why are we both doing it? Shouldn't we do it together? So that's the other thing that I've kind of picked up, is that we should be drawing in solutions from a much wider pool of resources than we currently do. Thank you.
okay. Thank you, Colin. Thank you.